All right, Kaina, what's up? Happy Friday to you. Thanks for a great quarter. I love working with you, and yeah, I hope your fall breaks off to a good start. I wanted to create this video to support you as best as I could. I know there's other resources out there, but hey, I thought it'd be more meaningful if it came from me, and showing you some problems that we will probably see in the future, or similar problems that we'll see. I also wanted to let you know that I believe in you 100%, and we're going to get through this together, and I got your back the whole way. Okay, so let's do this. Let me pull over to the notability problems I want to look at. All right, so we've got this problem, okay? 15 and 16 are both somewhat similar insofar as they're in a sense like break-even type problems, which is what Mr. Mike would call them, okay? So here's what we mean. If we go out to bowling, okay? This first bowling alley has these charges, okay? That's how they charge their customers. The second bowling alley is gonna charge less for shoes, notice, $2 for shoes compared to $5 for shoes up here. But it's going to cost more per game, $3 per game compared to $2 per game at the first alley. So at some point, they must cost the same. I know this question is, which is a better deal, but that should all depend, okay? That would all depend. For example, if we took this first bowling alley, okay, did this first bowling alley, and we only played one game, we're gonna rent their shoes, so $5. That's a given unless we have our own shoes. Not everyone has their own shoes, so it's gonna cost $5 for the shoes and $2 per game. So let's say we play one game. This will cost $7. $7 for one game. And if we go to the second alley, okay, it will cost $2 for the shoes, so we gotta rent the shoes, and $3 per game, but we're only playing one game. So this is gonna cost $5. So in this case, the second bowling alley is gonna be the better deal. However, the more games we play, for example, suppose we play 10 games. Okay, suppose we play 10 games. This is gonna cost, bowling alley A is gonna be $20 for 10 games, because it's $2 per game. So $20 for the 10 games plus 5, so that's going to cost $25 for 10 games. And 10 games equivalent here at this bowling alley, 10 games is going to be $30. Why? Because it's $3 per game. It's going to be $30 plus the 2 for the shoes, so that's going to cost $32 total. So at that point, there's no idea what the better deal is, but what we are concerned about is, when are these deals going to be the same? Okay, when are these deals going to be the same? Because it will all depend. So here's the thing. What are our variables? Our variables will be, well, as we described it, you can see we played games. Okay, we can play a different amount of games. So we can call this G. G will be the number of games we play. Okay, and the more games we play, it will affect our cost. Okay, so let's make C equal to the cost. Now, note, I always encourage you guys to start with a key. Start word problems with a key, meaning this. Okay, we have to know what our variables represent. Okay, my next tip is one sentence at a time. First bowling alley, let's concern ourselves with this only. Okay, this only. It costs, the cost of the first bowling alley, so I'll start with C, equation 1. C, the cost of the first bowling alley is $5 per shoe plus $2 per game. Only one of those will keep going up. It's not the shoes, because we can rent the shoes all night long. It's the games, because I could play, let's say, 3, 4, 5 games. It all depends. It can vary. So the cost at bowling alley A will be 5 plus 2G. How is this equation working? If I play one game, I'm going to have $2. If I play 2 games, that's going to be $4. If I play 3 games, that's $6. 4 games, that's $8. And I, of course, have to add the cost of my shoes. So then once you get that, the second alley will cost $2 for the shoes that in that case, it's going to stand by itself, okay, plus $3 per game, plus 3G in this case. So again, how is this working? If I play one game, that's going to cost $3. If I play 2 games, that's going to cost $6. If I play 3 games, that's $9. So we're multiplying it by 3, okay? And of course, I need to tack on the 2 because that's for the shoe rental. Now, how am I going to solve this system? Well, we can solve systems one of 2 ways, by substitution or elimination. This is better suited to substitution. Why? Because the variables are isolated, okay? So all we need to do is basically take this, which is equal to C, this is equal to C, and I'm going to plug this in that C. Equation 1 is going into equation 2. The other logic behind that is this is the cost of the first alley, and this is the cost of the second alley, and I just want to know when the cost of the first alley is equal to the cost of the second alley. When the cost of the first alley is equal to the cost of the second alley. When are they equal? Okay. Now at this stage, this is an equation we can solve. We want variables on one side, numbers on the other. So I'm going to subtract 2G from both sides. 2G from both sides. And that leaves me G on the left, 2 plus G, and this leaves me a 5. And to get G by itself, I'm going to continue by subtracting 2 minus 2. And I will get G on the right equals 3. Okay? And what did G stand for? Oh, yes, G stood for the number of games. So after 3 games, they will cost the same. Okay? They will cost the same. Can I prove that? Yes. Let's plug this G back in to this equation and this equation. In the first equation, I'll do 3 times 2, which is 6. 6 plus 5 is $11. So it's going to cost me $11 to both 3 games. If I plug 3 into the second equation, I will do 3 times this 3, which is 9, plus 2, which is also $11. Yes, this is when they cost the same amount. Now, if we had to answer the question, which is a better deal, well, it all depends. If we play 3 games, it's equal. If we play more than 3 games, okay, this will be the better deal. Why? Because it's only $2 per game. Okay. This problem is really important for 1, substitution, okay, and solving if you have variables on both sides. Okay. All right, let's take a look at 16. Teresa is organizing a dinner. Raise money. It costs $100 to rent the dinner hall and $3 to make each dinner. These 2 pieces of information are the costs. Okay, that's money she has to spend for community fundraising, for example. She's charging $8 per dinner. This sentence pertains to how much money she's going to make. Okay? So how many dinners does she need to sell to break even? In this problem, what's the variable? What can change? What can change is she might have less people dining, or she might have more people dining. Okay? So D can stand for the number of dinners, or the number of people buying dinners, or the number of dinners she sells. So D is the number of dinners. Now, what's the other variable? Well, the more dinners she makes, okay, the more dinners she sells, the more money she can make. So Y will be money. And in this case, we will make no distinction between the money she needs to spend and money she needs to gain. Okay? So here's our first equation. We're at a system of equations to model her costs and revenue. Cost is how much we need to spend. Revenue is all the money we bring in. Okay? So here's our first equation. 1. The cost, Y, okay, because we're defining Y as money, but this will be dealing with costs. We've got to rent the hall. It's going to cost us $100. Okay, 1 cent at a time to rent the dinner hall. But then it's going to cost an additional $3 for every dinner we make, okay, because we have to buy supplies, we have to buy plates, we have to buy ingredients. So it's 3 per dinner, So we'll do 3 multiplied by dinner. How does this equation work for us? If we make 1 dinner, it's going to be $3. If we make 2 dinners, it's going to be $6 because it costs $3 for every dinner. But we need to add 100 because we're talking about all our total costs, all the total costs. Okay? Equation 2 will also have to deal with money, but this is going to be the money coming in. This is the revenue. How are we making money? Well, we're only going to make money if we sell dinners. It's going to be $8 per dinner. This is money coming in. This equation 2 will be money coming in. Money in. So this will be 8D. If we sell 1 dinner, we'll make $8. That's not going to be enough to break even. Nowhere close because we had to buy reserve the hall for $100. If we sell 2 dinners though, it's $16. 3 dinners, $24. Now here's the kicker. This system is like the first one insofar as the variables are isolated. We're going to try to use substitution. Okay, this expression goes in because it's equal to y. Because it's equal to y, we'll go in right there. Basically, we're going to do 100 plus 3D and set it equal to 8D. Another way of thinking about this, that's by pure substitution. We're going to set the costs equal to how much we make. That's breaking even when the cost matches how much we make, okay? Or how much money we could bring in is equal to the money we need to spend. Again, this is equations both sides, variables on both sides. We're going to bring variables to one side, numbers to the other. We've only got 100 over here. We'll leave that as it is. And solve for D is divided by 5 after subtracting 3D from both sides up here. And D is equal to 20. What does D stand for? D stands for, we have a key right here, the number of dinners. To check our answer, we plug this in back into here. If we make 20 dinners, that's going to be $60 for costs, plus 100 for the hall. That's $100.60 in costs. If we sell 20 dinners, how much money are we going to make since we sell them for $8 per dinner? Okay, so we plug this 20 into here, and we're going to make $160. Oh, yes. That's what it means by breaking even. Our costs are equal to how much we make. Okay? All right. Next. I really like this question. There's this student of mine, class of 22. She's a senior now, Nohea. She came up with a really cool problem. And these are similar to some of the other word problems you might see and we have worked on. So there's 17 cardio machines. Now, cardio machines come in many different flavors. There's like ellipticals, there's bikes, there's treadmills. So in this gym, there are either treadmills with 1 running surface or ellipticals with 2 pads for each foot. So there's 2 running surfaces. That makes sense, right? Yep, you got to put your left on the left and the right on the right, low impact. You know, you've probably seen some of those. Okay? There are 22 total running surfaces in the gym. How many are treadmills and how many are ellipticals? Okay, so we're always going to start a word problem with a key. This question often tells us what the unknowns are, of course. They wouldn't be asking us an obvious question, so what they're asking us are the unknowns. So let's call T. They want us to find how many treadmills are and how many ellipticals are. So T must be unknown. It's not just treadmills, not the brand of the treadmills, not the weight of the treadmills, size of the treadmills. It's the number of treadmills. Okay? E will be the number of ellipticals. Okay? Now, here's the thing. One sentence at a time. At this fitness gym, there's 17 total machines. So, looking at our key, it's T, the number of treadmills, plus E, the number of ellipticals, is 17. This equation is just saying how many machines there are. The number of treadmills, because that's what our variable T is, plus the number of ellipticals is 17. Now, the second equation has to do with surfaces. Now, a treadmill has 1 surface, so we're going to have 1T. But an elliptical has 2 surfaces, so we have 2E. let me pause there and explain what this means. E is the number of elliptical machines. So if we had one machine, there are 2 pedals. If there are 2 machines, elliptical machines, there are 4 pedals. If there are 3 ellipticals, there are 6 pedals. That makes sense, left and right. If there are 4 ellipticals, there are 8 pedals, 8 surfaces. Okay? That's why we needed to multiply the number of ellipticals by 2 to determine how many surfaces there are. And then the number of surfaces is equal to the number of treadmills, because if you have 8 treadmills, for example, you will have 8 surfaces. Okay? But the number of surfaces from the treadmills plus the number of surfaces from the ellipticals is, where are the number of surfaces? 22. Okay, now looking at this system of equations, this is beautifully set up for, you guessed it, elimination. Okay, I am simply going to reverse the order of these. Okay, put equation 2 on top, I'll call it equation A, and put equation B on the bottom. Why? Because I'm going to set up for something really interesting. Since these are both in standard form, that's how we know elimination is at play and maybe a good method. Okay. Now, I was telling students, don't just cross this out just because they're next to each other. They are crossed out by an operation. We're going to take equation A and equation B, and we are going to subtract them. If we added them, we wouldn't be getting rid of t, because it would be t plus t. That's 2t. That's not electroeliminating. But if we're doing t minus t, that will get rid of the t's. So we're going to subtract everything. T minus t, that's 0. 2e minus 1 minus e, that's 1e. I don't have to write the 1, but I'll write it anyway. And we have 22 minus 17, which is 5. And there we go. Okay, that is the essence of elimination. We have eliminated the t's. So we have e is 5. What does e stand for? E is the number of ellipticals. If e is 5, I'm going to look all over God's creation. I'm going to look at our 2 equations for the easiest one to plug it into. Either one will work. I'm going to plug it into the first one. I'm going to plug 5 in where e is, because 5 is equal to e. I'm not going to put 5 near the e. 5 is the e. So in equation 1, I'll have t plus 5 equals 17. That implies that t is 12 after I subtract 5 from both sides. And so I have 12 treadmills and 5 ellipticals. Now, let's check our answer. Is that 17 cardio machines if I had 12 treadmills and 5 ellipticals? Yes, that's 17 machines. How about running surfaces? Well, that would be 12 surfaces from the treadmills, and since an elliptical has 2 each, that would be 10 surfaces. So in total, I would have 12 plus 10 surfaces, so that's 22 running surfaces. That's how we check our answer. Everything's beautifully consistent. Okay? All right. Now, you will have seen these 2 questions, and I'm not sure if you did them, though. I would say this first one is like the treadmill question. This second one is like the dinner question where we need to rent a banquet hall. So let me walk you through these. There's a test. There are 2 pointers and 4 pointers, almost kind of like basketball and sports. There's 2 pointers and 3 pointers. There's also free throws too. We could make one with football. That would be a really interesting systems of equations word problems, by the way. Something with field goals and touchdowns. Okay, and it would be a certain number of scores, and then that would lead to a certain number of points. It'd be a really similar setup, and maybe something we could talk about in person. But anyway, there's 2-point questions and there's 4-point questions. So how many of each type of question? Well, since we're asking that is obviously the unknown. Okay, that's what we're trying to solve for. Those are the unknowns. So let's talk about this. Let's call, we can make up any variable we want, but let's call it small and big. Yeah, sure. Low and high. Let's call it low and high, L and H. L is the number of 2-point questions. 2-point questions. H will be the number of 4-point questions. Okay. How do I know to make that as our key? Because we're always going to have two variables and two equations. For a system of equations, we need more than one equation. And there will be two unknowns, always, in our the ones we're practicing. And it's basically asking that. How many types of questions are there? How many of each type? So how many lows, 2 pointers, and how many highs, 4 pointers? Okay. So how will this work? One piece of information at a time. There's 40 questions on the test. Notice I'm only going after like the first 3, 4 words in the question. 1. There's 40 questions. So the number of 2-point questions plus the number of high-point questions is 40. Yes, there are 40 questions on this test. Equation 2. This equation, the first equation has to do with questions. The number of questions, the number of low questions plus the number of high questions is 40. This next one will have to do with points. 2 times the number of low questions plus 4 times the number of high questions is 100. Now, how is this equation working for us? If there were 3 low questions, that would be worth 6 points. Again, this entire equation has to do with points. L is the number of low questions. If there were 5 low questions, that would make 10 points. If there were, let's say, 8 low questions, that would be 16 points from those questions alone. Okay? Now, same with the high questions. H is the number of 4-pointers. So if there were 5 4-point questions, that would be 20 points coming from these. It would be worth 20 points. If there were 10 high questions, that would be worth 40 points. If there are 20 high questions, that would be 80 points of all the tests. Okay? Now we look at this and say, oh, these are nicely aligned. So that would lead us towards solving by elimination. Okay? Now how are we going to do elimination? I'm going to reorder again because I usually want the high ones on top in order to avoid negative numbers. So this is equation 2. Equation 1, I'll write again just for the sake of showing you. Okay? L plus H is 40. Notice, none of these are matching yet. But what we can do if we're solving by elimination is get them to match. How? By multiplying one of these equations, probably the lower one in terms of L and the H, in order so that we can get them to match. So if I want the L's to match, for example, I could multiply this equation, both the left side and the right side, by 2. Okay? So here we go. Here's equation 2, untouched. I'll write it in blue. Equation 2. All right, I'm going to write it below, but this is 2, okay? 2. 2L plus 4H. I am not doing anything to it. Equals 100. Now in orange, I'll switch over. Instead of rewriting equation 1, I know I got to get these L's to match. So I'm going to multiply equation 1, left side and right side, by 2. So here's how I notate that. This is just a reminder to myself what I'm doing. 2 times equation 1. So I'll get 2L plus 2H. Yep, 2L plus 2H equals 80. Again, these don't just cancel by default automatically. We have to do something to get them to eliminate. In this case, we are going to subtract. Subtracting is the organizing, the main operation. So if you subtract, that leaves 0L. Okay, so that's what we mean by elimination. And we get 2H equals 20. Divide by 2, so we get H is equal to 10. What does H stand for? H is the number of 4-point questions. How many of each type is the question? So I still need to find L, the number of 2-pointers. So I'm going to look all across God's creation, and I have H is 10. Where am I going to plug it into? Which equation? I'm going to plug it into, looks like equation 1 might be easier. So here's equation 1, but instead of writing H, I'm going to write 10. And there we go. L plus 10 is 40. That implies that L is 30. And that's the number of low questions. 30 low questions, 10 high questions. Can we double check that? Yep. Do these add up to 40 questions? Yes. If the low questions are 2 points each, that would amount to 60, oops, not dollars, 60 points from this, and high questions are worth 4 points each, sorry. And if we have 10 of those questions, that will be 40 points. So 60 points and 40 points, that's a total of 100 points. All right, and that's how we know we are right. Okay, this one, similar to the dinners, I'm gonna make, we clean offices. Okay, we're gonna start this business. We've gotta buy 315 to start an office cleaning business. How come? We're gonna buy uniforms for our staff. We are gonna supply them with gloves, masks, hats, so they look professional, and also basic cleaning supplies like sanitizer, mops, etc. So we gotta spend initial amount, $315, one time. Now, the offices we're gonna clean, we're gonna agree to restock their paper towels and soap. So it's gonna cost $4 per office. This is a cost. It's what we spend. What do we get in exchange? If we're spending and spending, we're gonna go out of business if we're not making money. So the thing is, we are gonna charge people $25 per office. That's money that we're gonna make. So what's the thing? How many offices to break even? This is the clue what our unknown is. Of course, that can vary. Sometimes maybe no one's going to hire us and we're just going to lose money. Or maybe we can clean 150 offices. Who knows? Okay, so that's going to vary. The number of offices, let's call it X, just for kicks. You could call it anything you want, but this is the number of offices, not just offices, because I'm going to say what the size of the offices, the type of floor in the offices. No, it's the number of offices. And Y is the more offices we clean, the more money is at stake. Y is money. And in this case, again, we're going to make no distinction on money spent and money earned. So equation 1, this is going to be costs. Costs, what we spend. The money we spend, Y, the money we spend is equal to $315 because we had to start our business, plus 4 for every office. In the cleaning supplies, in the soap and paper towels. We clean one office, it's going to cost us $4 in supplies. 2 offices is going to be $8 in supplies. 3 offices is going to be $12 in supplies. So that's how this equation is working. Plus we need to add it to $315 because that was our startup cost. The second equation is how much money we make. Money made, also known as revenue made, or money coming in. Money in. The money coming in is $25 per office. We can't just leave it as $25 because we don't want to just make $25. If we clean 1,000 offices, what? All we're going to get is $25? No, it's $25 per office. So if we take 25 and then multiply it by the number of offices, then that's how much we're going to make. For example, how is this equation working for us? If we clean one office, $25. If we clean 2 offices, $50. If we clean 3 offices, $75. If we clean 4 offices, $100 is how much we're going to make. Now, to break even, the money we make, we want it to equal the money we've spent on our business. Okay? The money we make has to equal the money we spend. And this should look familiar. This is also done by pure substitution. Since this is equal to Y, that goes in for the Y. Okay, or since this is equal to Y, it can go in there. It doesn't matter. We're just setting this and this, the costs and the how much money we make equal. Okay, so at this stage, we can solve variables on one side, numbers to the other. So we got 21x equals 315. 315 divided by 21. I believe that's, what do I remember, 15? I'm taking out a calculator. 315 over 21. Yep, it's 15. Okay, x equals 15. And what is x? X is the number of offices. To double check that, okay, I can plug in 15 here, and I can plug in 15 here. Why would we do that? 1, we can find the costs, and 2, we can find the money we make, and it should be the same. I'm going to grab my calculator. 15 times 4, that's 60. Plus 315, that's 375. That's how much we got to spend in supplies if we cleaned 15 offices. And in terms of money we make, if we do 25 times 15, which we should have that number already, but I'm just double checking, that should be, I'm sorry, we don't have that number. But so we're going to plug it in here, $25 per office and 15 offices. 25 times 15 is 375. That's how much money we're going to make. And notice they are equal, so we've broken even. If we clean more than that, then we're making more money because we're charging people $25 in office and we're only spending $4 for the supplies to restock that office. Okay, kinda, that's it. You can rewatch this video as many times as you want. Please ask me any questions and I'm here for you. Thanks, bud.